All right, let's take a look at a few more problems that are going to use some inequalities so we can get some practice with that. So the temperature T at the base of a mountain is 90 degrees, and it drops by 5 degrees for every 1,000 feet you climb in elevation. On what part of the mountain is the temperature cooler than 40 degrees? So how far up do we have to hike before we probably need to put a jacket on is kind of what we're asking here. And we're going to let H be measured in thousands of feet for the base of the mountain. So when H is 1, that represents 1,000 feet. When H is 2, it represents 2,000 feet. So the way that we're going to start this is by actually just writing a linear function or a linear equation using an equal sign. So we know that the temperature is going to be, it starts at 90, and it's going to drop 5 degrees for every 1,000 feet we climb, and we're representing that with an H for that elevation height there. Okay, so hopefully that makes some sense where I came up with this. And now what I'm going to do is I'm going to turn this into a linear inequality. So what I'm interested in is when the temperature is cooler than 40. So in other words, when the temperature is less than 40. But instead of writing T is less than 40, I'm going to replace it with this so that I can solve for H. So I have 90 minus 5H is less than 40. Okay, and then I just need to solve this for H. So there's a couple ways of doing that. Let's see. One would be to move this 90 over, which I can certainly do. And that gives me a negative 5H is less than a negative 50. So I need to divide by this negative 5. There's one little hiccup here. So if you're working with inequalities, you either multiply or divide by a negative number, then the inequality sign has to get flipped over going the other direction. So when I do this, what happens is instead of it going this way like it was, it's going to go the other direction. And then negative 50 divided by negative 5 is 10. So when H is greater than 10, we're going to be cooler than this 40 degrees. Okay, and remember that H is measured in thousands of feet. So if we are above 10,000 feet, the temp is going to be less than 40. Okay, so hopefully that kind of makes some sense of as an interpretation of the work that we just did here. You only need to flip this inequality sign if you're multiplying or dividing by a negative number. So if instead I had solved it a little bit differently, so if I added 5H to both sides, then that gives me 90 is less than 40 plus 5H. And if I subtract that 40 over, then I have 50 is less than 5H. And now when I divide both sides by 5, I don't need to flip this sign over because I'm divided by a positive number. And I still get H is greater than 10. Okay, so either way you solve this, as long as you're following the rules of mathematics and algebra, you should end up at the same answer. Okay, I would like you to pause the video and give this next one a try. So Keith has $500 in a savings account at the beginning of the summer. He wants to have at least $200 left in the account. He's going to pull out $25 a week for food, clothing, and movie tickets. I suspect that Keith probably does not live in the year 2020 because I don't think $25 is going to get you very far. But we'll go with it anyway. So how many weeks can Keith withdraw money from his account until he hits this mark of 200? So we're going to let X be the number of weeks. And then I'd like you to start by writing a linear equation here. So the amount of money he has in his account at any given time. So A is equal to what? So fill that in with an equation. Okay, so hopefully you started with that 500 and then you're subtracting 25 off for each week. So it looks like that. And now we're going to turn this into, he wants to have at least $200 in his account. So he wants A to be greater than or equal to 200. So I'd like you to go ahead and pause that video, see if you can actually finish figuring this out and figure out how many weeks he can afford to do this for. I have some confidence in you, so give it a try. You got this. And if not, we'll come back to the video together and work on it. All right, so let's take a look at this. I have 500 minus 25x is greater than or equal to 200. I am going to add 25x to both sides. That leaves me with 500 is greater than or equal to 200 plus 25x. And then I'll subtract that 200 from both sides. So it gives me 300 is greater than or equal to 25x. And now I can divide by 25. And I don't need to flip the sign because I'm dividing by a positive number. So that gives me that x has to be less than or equal to 12. Okay, so what does that mean? And let's make sure that this makes sense to us. So this means that Keith has enough money for 12 weeks or less. Right? And that makes some sense. So here we were looking at more than, right? Above 10,000 feet. Here we're looking at less than, because if he went more than 12 weeks, if he just went on and on forever, just always taking $25 out each week, he's going to run out of money and then his bank account is going to get closed for overdraft. Okay, so this answer does make some logical sense when we look at it. All right, and then we have one last one. So this one is actually going to use two inequalities. So let's take a look at it. It says you can work a total of no more than 10 hours each week between your two jobs. So you have two jobs. One is house cleaning, and it pays $5 an hour. And then you also have a sales job that pays $8 an hour. All right, you need to earn at least $56 each week to pay your bills. We're going to let X be the number of hours worked house cleaning. So let's put HC for house cleaning. We're going to use the letter X for the number of hours, and you make $5 an hour at that job. And then the sales job, it says Y is representing the number of hours worked at your sales job. And that job pays you $8 an hour. And we're going to write a system of inequalities that shows the various numbers of hours you can work at each job. And we're going to work on this graph. So let's start by looking at some of this information we haven't used. So let's start here. You can work a total of no more than 10 hours each week at your two jobs. So if X is the number of hours house cleaning and Y is the number of hours in sales, then X plus Y has to be less than or equal to 10. Otherwise, you would be working more than the 10 hours, and that would break this rule. So there's one of our equations. And then we have a second equation here that we can get, and that's related to this money here. So the house cleaning pays 5, the sales job pays 8. So that looks to me like that's 5x plus 8y. And what we know about this, so this would be how much money you're earning. We know that we need to make at least $56 each week. So we need this to be greater than, we can do greater than or equal to 56. That works fine. Okay, so I have my two equations. And what I'm wanting to do is I'm wanting to plot these and kind of see if I can find some overlap here. So to plot these, what I need to do is move them into a y equals format so that I can put the y-intercept on here and then put the slope on if I can get this into a slope-intercept form. So this one's not too bad. I'll subtract x from both sides, and what that gives me is y is less than or equal to 10 minus x. All right, so what I'm going to do is I'm really going to graph y is equal to 10 minus x, and then I'll come back and deal with this inequality. So I'll start with putting my y-intercept on here. 7, 8, 9, 10. Okay, so there's 10. And I'm going down by 1. My slope is a -1. So down 1, over 1, down 1, over 1. Okay, so it gives me a couple of dots there. So let me go ahead and connect those. And now what I want to do is I want to shade in the part where y is less than 10 minus x. So that is going to be this part here. This is the less than side. But if you're ever not sure which side you want to shade in, a really great way to do this is to just pick a point on here. So this point here is x is 2, y is 1. So at that point, at 2, 1, if I plug that in here, I need to see if it's true or false. So is 1 less than or equal to 10 minus 2? Is that true? Yeah, well, 1 is definitely less than or equal to 8. That's true. And so if it's true, then whatever side that dot's on, that's the side you shade. So for example, let's look if I picked a dot over here. So this looks like 9. That point is 9, 5. So if I plug that in, is 5 less than or equal to 10 minus 9? So is 5 less than or equal to 1? That's a definite no. Okay, so if you get a statement that's false when you plug the point in, you don't want to shade that side, you want to shade the other side. All right, so hopefully that gives you a little bit of help with that. So there's one of our pieces. Then let's solve this piece and put it into slope-intercept form also, and we can plot it and work on that as well. All right, so I have 8y is greater than or equal to 56 minus 5x. And then I'm going to divide through by 8. So that gives me y is greater than 7 minus 5 over 8x. So 7 is my intercept. So there's that. And then my slope is negative 5/8. So I'm going to go down 5 and then over 8. So that's right there. I'll go ahead and connect those two dots. All right, and I'm looking for greater than here. So the greater than is going to be everything above this line here. So specifically, kind of looking at this, but really what I'm interested in is just this area that overlaps where it's both blue and red, right? Because I shaded everything under the blue line and everything above the red line. And so that is this region here. Okay, so we've shaded the region that is going to meet both of these inequalities at the same time. So that means I'll be able to stay under my 10 hours, but I'm going to make more than $56. All right, so let's pull a point out of this region. So this point right here is 2, 2, 3, 4, 5, 6, 7. Okay, so what that means, so on my x-axis, I have the hours house cleaning, and this is the hours in sales. So if I do 2 hours house cleaning and 7 hours sales, then I should be able to meet both of those criteria. So any points that fall in this region they have in common are going to satisfy those inequalities. All right, so hopefully that gives you a little bit of insight into that, and I will see you back for chapter 2.